Hello students, welcome to online lecture series of discrete mathematics. Now today we will see the handshaking theorem or handshaking lemma. So this for this handshaking theorem, what is this handshaking theorem? The sum of degree of all the vertices in a graph G is equal to twice the number of edges in the graph. So this is your handshaking theorem. That is, mathematically it can be stated as the degree of all the vertices, summation of degree of all the vertices is equal to twice the number of edges. So we'll see the example later. Then Dijistra's algorithm. So this algorithm maintains a set of vertices whose shortest path from source is already known. The graph is represented by its cost adjacency matrix, where the cost is the weight of the edge. In the cost adjacency matrix of the graph, all the diagonals values are 0. If there is no path from source vertex Vs to any other vertex Vi, then it is represented by the infinity. In this algorithm, we have assumed all the weights are positive. Initially, there is no vertex in the sets. Second, include the source vertex Vs, right? The source vertex in S. Determine all the path from this source vertex to all other vertices without going through any other vertex. And third, now include that vertex S, which is the nearest to the source vertex, and find the shortest path to all vertices through this vertex and update the values. Then fourth, repeat the step until n-1 vertices are not included in S if there are n vertices in the graph. After the completion of the process, we got the shortest path to all the vertices from the source vertex. So in a Dijistra's algorithm, here we have to find out the shortest path from one source, from source to a destination. So you have to first initially you have to consider any vertex as a source vertex, and then find out the distance from that source vertex to the remaining vertices. Whatever distance is a minimum distance, so we have to consider that path. And include that vertex in your set S. Again, find out the distance from that whatever vertices included in that set, right? So find out the path from find out the distance from that vertex to the remaining vertices which are not included in that set, right? Same again, find out the minimum distance from that vertex to the remaining vertices, right? So you have to repeat this step until no vertex is remaining, right? So whatever examples based on this Dijistra's algorithm we'll see later, right? So how to find out this shortest path from source to destination. Next, so the problems based on the handshaking lemma. A simple graph G has a 24 edges and a degree of each vertex is 4. Find the number of vertices. So in this problem, so there are number of edges are 24 and degree of each vertex is 4. Here we have to find out the number of vertices. So let's consider the number of vertices in the graph is equal to n, And by using a handshaking theorem or handshaking lemma, we have sum of degree of all vertices is equal to twice the number of edges, right? So sum of degree of all the vertices. So we have considered there are n number of vertices, right? And degree of each vertex is 4. So n into 4 is equal to 2 into twice the number of edges. So number of edges are 24. So n into 4 is equal to 2 into 24. So therefore n is equal to 12. So number of vertices in the graph, right, is equal to 12. The next example, a graph contains 21 edges, 3 vertices of degree 4 and all other vertices of degree 2. Find the total number of vertices. So here number of edges are 21, number of degree 4, right? So how many vertices are there? 3. So 3 vertices of degree 4. All other vertices are of degree 2. So here let the number of vertices in the graph is equal to n. So here we have to consider number of vertices are n by using handshaking theorem. So sum of a degree of all vertices is equal to twice the number of edges. So here number of vertices are n. So from that n vertices, 3 vertices of degree 4. So 3 into 4. So remaining vertices are n minus. So remaining vertices are n minus 3. Because here we are consider a total number of vertices are n, right? So from that n vertices, 3 vertices are of degree 4. So 3 into 4, right? So plus, so 3 vertices. So n minus remaining vertices are n minus 3, whose degrees are, so all other vertices are of degree 2. So n minus 3 into 2. So right, that is equal to 2 into number of edges, that is 21. So 12 plus twice n minus 6 is equal to 42. So twice n is equal to 42 minus 6, and is n equal to 80. N equal to 80. So total number of vertices in the graph is 80. Graph is 80. So next example. So last example on this handshaking theorem. A simple graph contains 35 edges, 4 vertices of degree 5 and 5 vertices of degree 4 and 4 vertices of degree 3. Find the number of vertices with degree 2. Find the number of vertices of degree 2. So here number of edges are 35. Number of degree, right? So there is 4 vertices of degree 5. 5 vertices are of degree 4 and 4 vertices of degree 3. So here we have to find out the number of vertices with degree 2. So let the number of degree 2 vertices in the graph, we have to consider n. So assume that n vertices of degree 2. So using this handshaking theorem, right? So we have sum of degree of all vertices is equal to twice the number of edges. So sum of degree of all the vertices. So 4 vertices of degree 5. So 4 into 5 plus 5 vertices of degree 4. So 5 into 4. 4 vertices of degree 3. So 4 into 3 plus, here we assume that n vertices of degree 2. So n into 2, that is equal to twice the number of edges, that is twice into 35. So 20 plus 20 plus 12 plus twice n is equal to 70. So 52 plus twice n is equal to 70. So twice n is equal to 70 minus 52. So that is n is equal to 9. So number of vertices of degree 2 is equal to 9. Is equal to 9. Okay, so we stop here. Next session we will see the next topic.